Hello everyone, and welcome back to EducateLy's chemistry course. In the previous video, we looked into the definition of chemistry and some of its applications, but today we'll be learning about the fundamentals of the periodic table. You'll learn about the elements that make up the periodic table and some of their fundamental properties. You'll also learn how to interpret the standard notation of elements in the periodic table. So, without further ado, let's jump into it. Before we explore the periodic table, let's understand what an atom is and what its components are. So an atom was once thought to be the smallest particle in the universe, and we used to think that we can't break it down further, but we now know that atoms are actually made up of three fundamental particles, and those are protons, neutrons, and electrons. These are known as the subatomic particles. A proton is a subatomic particle with a positive charge and a mass of 1 AMU. AMU in this case stands for atomic mass unit. A neutron is a subatomic particle with no charge, but it also has a mass of 1 AMU. An electron, on the other hand, is a particle that has negative charge, but unlike protons and neutrons, it has no mass. So an important thing to remember is that the electron orbits the nucleus. So the electrons are kind of spinning around the nucleus, and the nucleus is just kind of a bundle of the protons and the neutrons. So the things with mass are in the center, and the massless things, the electrons, are orbiting around. So now let's talk about what a periodic table is. So the periodic table is just a table listing all the elements that we've discovered, and it's arranged by atomic number, and it lets us see what chemical properties certain elements have in common. So you're probably wondering what an atomic number is. And so quite simply, the atomic number is the same thing as the number of protons an element has. So every element has a unique atomic number, and therefore atomic numbers are used to identify an element. So in general, if two atoms have the same atomic number, they are the same atom. Another property of elements, which is displayed in the periodic table, is their atomic mass. So down here, you can see the atomic mass of hydrogen. And so the atomic mass is just using the mass of neutrons and protons. And so since they both have a mass of 1 AMU, we can essentially use the atomic mass as the number of protons and electrons in that atom. So in the case of hydrogen, we just have one proton, and we have no neutrons in hydrogen. So that's why its atomic mass is the same as its atomic number. So as you can see, our periodic table is divided into rows and columns. So chemists like to use fancy terms to describe simple things. So in our case, our columns are called groups, and our rows are called periods. So there are 18 groups on our table, and there are 7 periods. So just as an exercise, let's try locating carbon on our table. So I'll pause for a bit, see if you can locate it. So if you correctly found carbon, you would say it's in the second period and the 14th group. Now I want you to try 2 more on your own. Try to find potassium with the symbol K and chlorine with the symbol Cl. So if you need extra time, go ahead and pause the video right now. Right, so potassium is located in the first group, so first column, and the third period, or third row. Chlorine, on the other hand, is located in the 17th column and the third row. So 17th group, third period. Okay, so let's try to put everything we learned together. So let's take iron as an example. Fe is the symbol representing iron, and in the top left corner we have the atomic number of iron, which is 26, and in the bottom the atomic mass is 56. So let's try the same thing with oxygen. Oxygen has O as a symbol representing it, and the atomic number is 8, and the atomic mass of oxygen is 16. So a common question you'll come across is how many neutrons does an element have? And so the periodic table actually gives us all the tools we need to answer this question. So, for example, oxygen, we know that it has an atomic number of 8. So that means it has 8 protons. And we also know it has an atomic mass of 16. So that means that if we take the protons and neutrons together, we'll end up with 16 subatomic particles. So simple subtraction tells us that we have 8 neutrons in oxygen. So as one final example, let's look at aluminum. Al is a symbol representing aluminum. Its atomic number is 13 and its atomic mass is 27. Can you figure out how many neutrons aluminum has? Pause the video here and try to solve it for yourself. So hopefully you're able to figure that out. As we learned earlier, you just subtract the number of protons from the atomic mass. So in this case, the number of neutrons equals 27 minus 13, which comes out to 14 neutrons. So that brings us to the end of the video. Thanks for exploring the periodic table with us, and we'll see you in the next one.